Dear students, in today's class we learn the properties of arithmetic mean. Properties of arithmetic mean. The first properties of arithmetic mean is the summation of the deviations of all the observations from its arithmetic mean is 0. So if we calculate an arithmetic mean and if we deduct all the observations of that mean from the mean, we get the total 0. So in symbolically we can say summation of x minus x bar is equal to 0. So x's are all the observations and from their mean, if we deduct all the values and whatever value we get, if we total it, the total will be 0. This is because of here mathematical based formula. So here all the observations, each and every observation is taken into consideration while calculating the arithmetic mean. So that we add all the observations and we calculate arithmetic mean. Just we don't count here. So we add all the observation. So we get x minus x bar total is equal to 0. And the second property is the square of the deviations of observations from its arithmetic mean is the least. That is, if we square these x minus x bar values, the deviations from arithmetic mean, if we square them and if we total it, so that total will be the least. That is the summation of x minus x bar square is least. If any other value than the arithmetic mean, if you take and if we take the deviations, if you deduct the value, a constant value from all the observations and if you square it, then the total will not be least. It will be more than the whatever total we get from its arithmetic mean. Okay, so let us take it by a small example. So x observations. So I take 2, 4, 6, 8, 10. So 5 observations are there here. The formula for x bar is equal to summation x divided by n. So summation of x, 2 plus 4, 6, 6 plus 8, 12, 12 plus 8, 20, 20 plus 10, 30. So 30 divided by n. N is number of observation 1, 2, 3, 4, 5 observation. So 30 divided by 5 is equal to 6. So now if we divide 6 from all the values, so that is x minus x bar. So that will be 2 minus 6 is minus 4, 4 minus 6 minus 2, 6 minus 6 0, 8 minus 6 plus 2, 10 minus 6 plus 4. So minus 4 plus minus 2, minus 6 plus 0 minus 6 plus 2 minus 4. Then if you add 4, minus 4 plus 4 is 0. So the total of x minus x bar is 0. And next square if we consider. So that is x minus x bar square. So already x minus x bar we have calculated. If we square them, so 4 square. Minus 4 square is 16. Minus 2 square is 4. 0 square 0. 2 square 4. 4 square 16. So 16 plus 4 20. 20 plus here 20 is 40. So the total of x minus x bar square is 40. Let us cross check both by taking a value less than arithmetic mean and one value more than arithmetic mean. So first we will consider 5, x minus 5. So 2 minus 5 minus 3, 4 minus 5 minus 1, 6 minus 5 plus 1, 8 minus 5, 3, 10 minus 5 is 5. So total here minus 3 plus minus 1 is minus 4, minus 4 plus 1 minus 3 and plus 3 0 and 5. So the total of x minus 5 is 5. So it's not 0. So by this we confirm that if we take x minus other than arithmetic mean, if you take any other value, the total will not be 0. And if you take it by arithmetic mean, it will be 0. Then check for second property. So that is the x minus 5 square. X minus 5 square. So minus 3 square is 9. 1 square is 1. 1 square again 1. 3 square 9. 5 square 25. So 25 plus 9 34. Plus 1 35. 35 plus 10 45. So now we have taken a number less than its arithmetic mean. Let us check by taking a value which is more than its arithmetic mean. Let us take 7. So x minus 7 and so it's square. X minus 7 square. So 2 minus 7 we get a minus 5 and its square 25. Then 4 minus 7 minus 3 and its square 9. Next 6 minus 7 minus 1 and its square 1. Then 8 minus 7 plus 1 and its square 1. And 10 minus 7 is 3. 3 square is 9. So now the total. So here minus 5 minus 3 minus 1 minus 9 we get, and 4 we get minus 5. So it's less than 0. And here 25 plus 10 35 plus 10 45. So again it's not least, as it's more than the x minus x bar square. So by here we can say that the property of arithmetic mean, they are right. So x minus x bar is 0. Summation of x minus x bar is 0, and summation of x minus x bar square is the least. If you take any other value than its arithmetic mean, the sum of deviations from any constant is not 0, and the square of deviations of observation from any other constant value is not least here. Okay, and the third property of arithmetic mean, that is, if we have certain set of observation and their mean, and another set of observations and their mean, that is, if you know the arithmetic mean of one observations and the number of observation, and another observations arithmetic mean and their number if you know. Okay, if we name a first observation as x1 and x bar 1, and their number of observation as n1, and the second one x2, second observation is arithmetic mean and their number of observation is n2. When we know both information, now if you want to know the combined arithmetic mean of all the observations, for example, in a classroom of 20 students, suppose 12 boys are there and 8 girls are there. 12 boys and 8 girls. And if we have separately calculated the arithmetic mean for average marks for 12 boys, and also we calculated separately arithmetic mean for, that is, average marks of girls. Now we want to know the average marks scored by the entire class of 20 students. Then here, by having a third property of arithmetic mean, that is combined arithmetic mean. So if you want to calculate the find or combined arithmetic mean, x bar c, so combined arithmetic mean for two set of observations and their number if you know, then it will be x bar 1 n1 plus x bar 2 n2 divided by n1 plus n2. So this is taken from the formula of arithmetic mean again, because the formula of arithmetic mean is equal to summation x by n. So to calculate any mean, we need to know summation x. If you know two summations of both the observations, then by adding the observation, we can calculate combined arithmetic mean. So just we have multiplied, cross multiplied. So x bar is equal to summation x by n. So x bar n is equal to summation x. So here summation x of first observation and summation of second observation divided by total number of observation. So by this formula we can calculate the combined arithmetic mean when we know the observations, number of observation and mean for two different or more than two different observations. Okay, and even we can add here. So if for 3 observation, just add here plus x bar 3 n3 and here plus n3. So on, we can continue the formula here for any number of observations and their arithmetic mean. Calculate some problems on combined arithmetic mean. That is, we can say problems on properties of arithmetic mean also. So first problem I will read here. The mean age of a group of 40 students is 16 years and the mean age of another group of 60 students is 20 years. Find the mean age of 100 students together. So in the certain education institutions, they have made 2 groups, maybe first year and second year. And first year, there are 40 students and their age is 16. 40, we name it as a N1 first group and their arithmetic mean is 16 years is x bar 1. And another set of group, that is 60 students, we name them as 60 students as N2 and their mean age, average is 20 years as x bar 2. So altogether 100 students average age we have to tell. Now here formula for combined arithmetic mean, x bar c is equal to n1 x bar 1 into n2 x bar 2 divided by n1 plus n2. So now x bar c is equal to n1 is 40 into x bar 1 is 60 plus n2 is 60 into x bar 2 is 20. So divided by n1 plus n2 is 100, that given in the problem itself. So now 40 into 16. So 40 into 16 is equal to 640 plus 60 into 20 is equal to 1200 divided by 100. So x bar c is equal to 640 plus 1200 is 1840 divided by 100. So combined arithmetic mean, that is the average age of entire institute, the group of 100 students is 18.4. So the average age of the 100 students is 18.4 years. Now let us take another problem on combined arithmetic mean. So here certain values, if some value is missing, we know the combined arithmetic mean and we don't know either x bar 1 or n1 or x bar 2 or n2, then how to find that missing value here. So we learn problem on that. So first one here, the mean marks of 2 sections A and B of a class is 62. So here they have given combined arithmetic mean of 2 classes, section A and section B, and the mean marks of both the section x bar c is equal to 62. Then mean marks of a student in section A is 70. Also mean marks, average marks of section A, we name it as a x bar 1 is equal to how much? 70 marks. The section A students, they scored 70 marks on an average. And if the number of students in section A and section B are 30 and 35 respectively, so that is n1 is equal to 30 and n2 is equal to 35, they have given. Then find the mean marks of students in section B. So section B's mean marks is x bar 2. We don't know, that we have to find now. So how to find? by applying the same formula which used to find the combined arithmetic mean. So that is here x bar c is equal to n1 x bar 1 plus n2 x bar 2 divided by n1 plus n2. So what all values we know, just fill them in the formula. So combined arithmetic mean x bar c is 62 is equal to n1 is 30 into x bar 1 is 70 plus n2. So n2 we don't know, n2 we know 35 into x bar 2 we don't know. So write just x bar 2 divided by n1 plus n2. That is 30 plus 35 is 65. Just send this 65 outside the opposite side. So it becomes 62 into 65 is equal to 30 into 70. 2100 is equal to 35 x bar 2. So now x bar 2. So here plus sign is there. So x bar 2 is equal to, so 35 x bar 2 is equal to, just we send this outside here. So here 62 into 65 is 4030. If you send this 2000 outside, it will become negative minus 2100. So 35 x bar 2 is equal to 4030 minus 2100 is equal to 1930. So x bar 2 is equal to 1930 divided by 35. So the sign between x bar and 35 is into. So if you take this opposite side, it will become divided by. So x bar 2, the second set students average marks is 1930 divided by 35 is 55.1428. So approximately 55.14. The average marks of the students in section B is the 55.14. Let us calculate another problem on missing value. So if n values are missing, then how to find that missing n value? So here there is a problem. Example 13. They are given boys and girls and their number. So just I'll write here boys, girls and number. So boys don't know and girls are 25 in total and their mean. So mean weight is 53 and 40. So mean weight in kg 50. Boys average weight is 53 and that of girls average weight is 40. And there are 25 girls. We don't know how many boys are there. And if combined mean weight of combined mean weight is 47.58 kg. So that is x bar c is equal to 47.58 kg. So individual girls number is 25 and their mean weight is 40. Boys number we don't know and boys mean weight is 53. And we know that combined weight of both boys and girls is 47.58. Now we have to find number of boys in that particular data. So we have this information. With help of this, let us calculate the the number of boys. So x bar c is equal to n1 x bar 1 plus n2 x bar 2 divided by n1 plus n2. So x bar c is 47.58 is equal to n1 we don't know, just write it as a n1 into 53 plus n2 is 25 into 40 divided by n1 we don't know, so n1 plus n2 is 25. So first send this entire denominator part opposite side. So it will become 47.58 into bracket n1 plus 25 is equal to n1 53 plus 25 into 40 is equal to 1000. So here if we open this bracket, 47.58 into 25, that is N1 plus 1189.5 is equal to N1 53 plus 1000. So here N1 into 47.58 is N1 into 47.58. N1 47.58. Now just send N1. So this N1 47.58, that side we will send, and this 1000 we will send opposite side. So it will become N153 minus, if you take this side it will become minus, so N1 47.58 is equal to, so 1189.5 minus 1000, so 53 minus 47.58 is equal to N1 5.42 is equal to 189.5. That is the difference between 1189.5 minus 1000 is 189.5. So if you divide it by 5 pointers, that is N1 is equal to 189.5 divided by 5.42. So N1 is equal to then 189.5 divided by 5.42 is equal to 34.963. So here N, we know that N is nothing but number of observations. So just we count the observation. We don't measure there. So here N, that is a frequency, total of frequency, cannot be in a decimal. It is should be an integer. So here N, that is the number of boys, is approximately 35 boys. Okay, so N1 is 35 boys in that set of observations. So in our next class we learn a problem where both N1 and N2 both are missing. If the total we consider is equal to 100, that is in a percentage or maybe in a ratios, we will find numbers, the proportion for a given mean of two set of observations.